All right, we have a slide angled 15 degrees below the horizontal. We want to know what is the maximum acceleration down the hill. When I draw this picture, I'm going to draw my angles very exaggerated so that you can see what I'm doing. So if I look at this, if my angle is here, okay, that's 15 degrees below the horizontal. Because of geometry and alternate interior angles, this one down here is also 15 degrees. All right. We now look at drawing our object on our incline. It's very important that you're making sure that your sort of forces are in the correct direction. Your weight always acts straight down. All right, that's my force of weight. My normal force always acts perpendicular to the surface, because as we went over, normal in math means perpendicular. So we have our normal force perpendicular to the surface. Because my acceleration is only going to happen along the surface of my ramp, I'm going to help myself out by setting my y-axis perpendicular to my ramp and my x-axis parallel to the ramp. That means that my math ends up being a lot simpler. So when I'm looking at the maximum acceleration down the slide, we're looking along the surface of the slide that's in the x direction. So we can start looking at the sum of the forces in the x direction is equal to the mass of my object times the acceleration in the x direction. And that's what we're solving for. So we need to look at what forces are actually in the x direction. Well, the way my coordinate system is set up, my normal force is only in the y direction. My force of weight, however, has part of it that's perpendicular to my ramp and parallel to my ramp. So that tells me I need to break that down into components. So I have my y piece and my x piece, FWY, FWX. And you need to be able to break these components, which you know have to be perpendicular to each other, out of the original vector. We need the angle, all right? Using a long complicated geometry proof, we find out that this angle in here is the same as this angle right here. So when we pull that triangle out, we get the fact that my force of weight is down. I have my force of weight in the y direction, my force of weight in the x direction, and we have this angle here. So now my x is not adjacent anymore, now it's opposite. So that tells me I need to use sine. Sine of theta is equal to my force of weight in the x direction over my force of weight. So my force of weight in the x direction is equal to my force of weight times sine of theta. Remember, force of weight is also mg, so my force of weight in the x direction is equal to mg times sine of theta. Okay. So now that we have this, we know that the sum of our forces in the x direction is just the x component of our weight. So force of weight in the x direction is equal to the mass times the acceleration in the x direction. We found the force of weight in the x direction came from here. So mg sine theta is equal to the mass times the acceleration in the x direction. Right? Notice now that we have acceleration on both sides of my, or not acceleration on both sides, mass on both sides of the equation. Because I have mass on both sides of the equation, they cancel. All right, so we are left with the fact that my acceleration in the x direction is equal to gravitational acceleration, times sine of my angle. In this particular case, we can find out what that is. We do need to assume first that our hill is on Earth, right, which is an assumption you can make unless otherwise stated. So 9.8 times sine of 15 degrees tells us that we have an acceleration of 2.5 meters per second squared. So that is the maximum acceleration that any object can have down that ramp. Right? And notice that, remember, the mass didn't matter. So any object going down that ramp, that's the maximum acceleration it can have if we are not dealing with friction. Now we're able to talk about the second part. What is the normal force provided by the surface of the slide for someone who is 84 kilograms? Remember, a normal force is in the y direction. So we're looking at the fact that the sum of my forces in the y direction is equal to my mass times my acceleration in the y direction. Well, I have acceleration along the surface of the ramp, but not perpendicular to the surface of the ramp. As a result, my acceleration in the y direction is 0. So my sum of my forces in the y direction is 0. Well, now I need to replace the left-hand side of my equation with my actual forces. Remember, any forces that are up we consider positive, any forces pointing down we consider negative. So my normal force up is positive, my force of weight in the y direction is down, considered negative. So normal force, my force of weight y is equal to 0, so my normal force is equal to force of weight in the y direction. Well, we need to actually find the force of weight in the y direction. Using the triangle we see over here, again, force of weight is now my adjacent side. So cosine of theta is equal to force of weight y divided by force of weight. So force of weight y is equal to force of weight times cosine of theta, or force of weight y is equal to mg cosine theta. So now that we have this, we can go ahead and plug it back into our other equation. We have all this information since we are given the mass of our object. We know it's on Earth. So the normal force provided to the person on the slide is .795 newtons.